Hi, it's Down Math. Easy solution to discuss local maximum and minimums and absolute maximum minimums and critical points and critical numbers. Basically, look at what they are and do some examples on how to determine them. This is useful in basically all of math and whatnot. So basically, let's start with local max min. Well, if we look at this one, let's just look at a graph. I'll show you what local max or min is. If you have a curve like something just like let's say like this and whatnot, and this is from interval B and A. So this is f of x, this is y, this is x. So basically, local max is defined as like let's say a value here. This is x here. So any value here close to it, this is the minimum value for a range of just locally a range of f of x values. So if you were to look at over here, and in this case right here, this one is a local minimum, because this one is less than all the values close to it. And similar to this one, all the values close to it, if we just write, let's say C here, so then this value here, this one is a local max because it's what's it called? Yeah, this one is local max because yeah, similar to this one, it is the largest value at this point and compared to all around it, compared to nearby around it. So this is a local max. And then yeah, so if we look at it, and then as you can see from here, if you have a local max or minimum, usually the derivative, the slope across this tangent line, has derivative of 0. This one has let's just write f of x equals 0 at this point here. This one's c, so we'll just put it as c. So basically, at the local max or minimum, it's usually, let's write usually. Yeah, usually f prime is equal to 0 or slope is 0. The reason I say usually is because if you have, let's say, a function, let's say like absolute value of let's say y equals absolute value of x, this one looks something like this, and then this one is local. Well, local and absolute. I'll show you what that one is soon. Absolute minimum. This is but the thing here, f at 0, this one f prime of 0 is not defined, so it doesn't exist. So this one doesn't exist. So you can't just use yes, you can't just use f prime of 0 there. So basically, this is basically all what local max and minimum is, and absolute max and minimum is just the same thing, except it just globally in that interval. Absolute max min, just write this here. So again, if you were to have a random graph like this one is x, this is y. So if you have something, let's say like this, and then from here and here, let's say you start off from, this one is A, this is B. So basically, absolute max is just the largest value. So absolute max is largest value in that interval. If this is f of x, so largest value in the domain, or whatever the domain or interval you have here. So largest value, and in this case, as you can see from the graph, it's just here. This one's f of a. This one is absolute max. It's called ABS max. And from here, you can see that the lowest value is this one here. So this is f of b. This one's just absolute. Yeah, absolute minimum. This is lowest, and then from here, these are just local max mins. As you can see, the slope here is 0 here. So f prime is 0 because it's yeah, it doesn't break apart like this one. So now if we look at absolute critical points and numbers, basically a critical number, the critical point is just the point, and the number is just the x value. So let's just go with critical points and whatnot. Numbers is the same thing, just how you use them in context. So a critical point or number is just a number such that, let's say number c, such that in the function f of x you'll have f prime of c is either equal to 0 or non-existent, or yeah, or doesn't exist. Non-existent or doesn't exist. So in this case, this one is a critical point here because it doesn't exist. And these cases here, this one is also a critical point or number. So this one's actually, to be technical, this is the critical number is C, and then this is the critical point. So it's critical point. And then yeah, just another side note on local max or minimum. If you have a function, let's say like y is equal to x cubed, this is a 3. This kind of looks something like this, where this slope here is 0. This one f of 0. It's a critical point here, but it's not a local max or minimum because it goes down here. Because near it you have some larger and some lower. So this is no max or min. But it's still a critical point. So that's still a critical point at 0. So at x equals 0, it's a critical number. It's a number. Okay, now to basically determine the absolute max and minimums, we are just gonna use the closed interval method. Let's write that down. Closed. So the closed interval method is to determine, basically finding max and minimums. Say absolute max and min. So let's say you had a function f of x. It's a continuous function, so it doesn't break apart and whatnot. It's continuous, and it's also, let's say, between intervals of a and b. So x is greater than a, greater than equal to a, and less than equal to b. So if you were to just get an idea of it, let's just draw a random curve right here. Okay, so if you were to just graph a random one like this, we'll just go like that. So then this is at b and this is at a. So this is the interval that we're graphing it out of, and this is f of x. So to determine this one, what we first have to do is find all of the critical points. So let's write step 1. We gotta find critical points or critical numbers. We'll just write find critical. And remember, the critical number is where basically f of c is equal to 0 or doesn't exist. And in this just a little quick general one, we could see that these values here, this one, let's call this C1, and this one C2, because this one, any parabola shape like this one, the slope is 0 here. This one, f of C1, f prime of C1 is equal to 0, so that's a critical point, and this is critical point 2, or critical number, and this one here, f prime of C2. So then these are the 2 points here. So we have to find the critical point of them. The point is just this point here. We'll just call the value. Just say find the y or f value. So then in this case here, we know that the C2 and C1 are critical points. So the y value is going to be f of C1 and f of C2. This is just generally speaking. And then for part 2, we got to find the endpoints. Find y or f values, just use it interchangeably, at endpoints. And in this case, this is 1 of the points, f of b, and this one right here, f of a. So then we get f of a and f of b. And in this case, also remember how this one we're finding if it's 0, and also if it doesn't exist, you can, or it doesn't exist if it was something like the absolute value one. So if you had something like this one, make sure you add this to your critical point. So then the third step is pretty straightforward. We just compare all the values, and then we see which is the lowest and which is the highest. Yeah, so we compare all these y values or f values, and then the lowest is the absolute minimum, ABS min, and the max max or largest is ABS max or absolute max. So now let's do an example to basically clarify this one. It's pretty straightforward. Hopefully you're following along. Okay, so let's say an example, f of x equals x cubed minus 3x squared plus 1 in the interval. Let's go with -2. So x greater than -2 and less than 4. So then if we were to follow the steps above here, so first one we gotta do is find the critical points and critical numbers. So we'll do step 1. Because this one, as you can see, this is a continuous function, so we could do that. And we could use a closed interval method, and there's no absolute values and whatnot, so it's not going to be a break in it. And so yeah, this x values, this is actually valid for all x values. So any number you put in there, there's no square roots and whatnot, so yeah, I don't have to worry about that. So then we could just do find the critical points. And remember, we know that critical points, f of c is equal to 0. Or it's when f of x is equal to 0. So let's get the derivative. F of x is equal to 3x using power rule. And then using power rule again. This one's 6x. So that's the derivative here. And then all we do is set it equal to 0 and solve for x. So solve for x, and those are going to be the critical numbers. Yeah, so let's just rearrange this one a bit better. So we have 3x squared minus 6x. Divide this both out by 3x, so we'll get 3x. This one's going to be x minus 2. Multiply this, going to get that equals 0. So this is equal to 0 when, if we look at both these, when x is equal to 2. And when this one is 3x equal to 0. So then x is equal to 0. This one, if you put a 2 in there, you get a 0. So we get, these are the critical numbers here. So x equals 2 and 0 are critical numbers. So now to get the critical points, all we gotta do is find the y value of it. So then we gotta plug in f of 2. This one's equal to, well, this is 2 cubed minus 3, 3 times 2 squared. What is that? Squared plus 1. So this just equals to 8 minus, this is 4, 12. 3 times 4 is 12 plus 1. This is -4 plus 1 is -3. And if we plug in f of 0 in here, this one is just, well, put a 0, 0, we just get 1. So this is our critical points here. And f of 2 is equal to -3. So yeah, these are the critical values there. So then we gotta go to find the end values. And then yeah, just endpoints, all we do is plug in the values. So we're gonna get f of -1/2. This one is equal to -1/2 cubed minus, what was this one? Was it a minus? Yeah, minus 3x squared plus 1. So 3 -1/2 squared plus 1. And this just equals to, well, this one's negative, it's cubed, so it's going to be -1/8. 2 to the 2 cubed is 8. Then this one is, it's going to be positive 3/4, -3/4 plus 1. So now common denominator just times by 2 on the top and bottom. So this we get, this one is 6, this is an 8. So then we can add these two up. And this will equal to 1 minus, -1 minus 6 over 8 plus 1. So we get equal to -7/8. Well, plus 8/8. This is all this one is, times 8 on top and bottom. And this one's going to be equal to, well, yeah, 1/8. So that's one end point value. Then if we look at the second one, this is f of 4. This is equals to 4 cubed minus 3 times 4 squared plus 1. This one is 64. 4 times 4 is 16 times 4 64. So we got 64 minus 3 times, this is 16 plus 1. And 3 times 16, we'll just put it here. This would be 3 times, that's 18. This is 1. This is 3. So that's a 4. It's 48. So then right here, 64 minus 48. This equals 64 minus 48 plus 1. And then this one, if you just put a 48 here, subtract it. This is equal to, it's a 14. This one is a 6. 1. So we have 16. You could just do it in my head. 16 and then plus 1 is 17. So we're equal to 17. So f of 4 is equal to 17. So we got the endpoint values, 17. This one's 1 over 8. So now we just compare all of them. So number 3, compare. And then we can see what we get. So if you're starting from the leftmost, we get f of 1 over 2. Negative 1 over 2 is equal to 1 over 8. F of 0 is the critical point. This one is, let's just call this C point. This one is equal to, let's see what it was, I forgot. So yeah, this one's 1 and F2 is negative 3. So this one is equal to 1. This one's also F of critical points. This is F of 2 is equal to negative 3, and f of 4 is equal to 17. And as you can see from here, this one is the minimum. Negative 3 is the lowest. So this is absolute minimum. That's all you got to do. This is absolute minimum. And then the max is 17 is the max, so this is absolute max. Well, that's all. Yeah, that's all we got to do. But also, you could also graph this out, and let's just grab the Google graphing calculator and see if we were right. Okay, so if we were to graph this one out, let's just write x cubed minus 3 times x squared plus 1. Let's just write from negative 1 over 2 to 4. So we graphed from that interval that we just did right here. Let's just drag this across here. So yeah, f of, yeah, so it's around 1 over 8 here. This is something like that. If you look at the y value there, this is around, it's 1 over 2. It's something really small here. Yeah, that's 0.5 here. Yeah, so it's close to that. And then if you go to 0 here, we get, this one's just 1. And then yeah, this one is a negative 3 right here at 2, so negative 3 you can see on this thing. When we drag it up here, get to 4. Where's 4? Let's just click it here. Yeah, so 17. So yeah, this is all right. Yeah, and that's all. Well, that's all for today. It's pretty straightforward how to get the local max and absolute max and minimum and whatnot. Just remember critical points. Critical points are usually just when the derivative is equal to 0, but if there's a break in it, like an absolute function, absolute value function, like this one right here, that's also a critical point. So we'd also take into consideration in this one. Well, that's all for today. Hopefully you learned, and stay tuned for another math easy